All right, good afternoon to everybody who's joined so far. I think we'll get started. I'm on a really bad network today, so I'm not going to spend too much time talking, and I'd rather turn it over to Ed and Andy anyway, since a lot of people are really interested in hearing an update on the Stardust platform, and I think they got a lot of good stuff to show. And as always, if you have questions during the talk, just put them in the chat room, and I'll make sure we interrupt the speakers to let them know. So Ed and Andy, I'll turn it over to you.
Yeah. Thank you, Jason. So yeah, we just thought we'd take the hour to talk a little bit about this Stardust platform. I'll do a little bit of a high-level intro into how we got to creating it, and then I'll hand off to Andy in about 5 slides to kind of go into the interesting details, if you will. And then if folks have questions, just interject along the path, and we'll be happy to address those as we can. So I guess we're going to go to the next slide, Andy. So first, I kind of want to show you a couple different pictures here, and what you see in the upper left is our current my.es.net portal. It's sort of a tried and true technology. It's been around, and it's SNMP based in this view you see here, and it's served us well for, I don't know, probably over 5 years. To the right, you see something newer. This is actually a Grafana based visual that we did. In both cases, we're showing the network status as you might have observed it during our live ESnet 6 unveiling back in the fall. And so you can see there's sort of 2 parallel flows going from the Midwest to the West Coast there. And while the new shiny thing is showing you a geographic view and the old is a logical layout, the newer one, it's showing you only the flow data that is part of the test, where the top one is showing you just aggregate usage. So while we have this enhanced capability to show the network flow over the network, and that's great, really the 2 things are largely the same, and the challenge is the same. And the challenge is how do we tell a compelling story with the measurement data we have? And that was true 5 years ago when we created the portal originally, and with this latest set of technologies that we'll be showing you today, it's still true. Next slide, please. And that's really what it's all about for us. Is we have a variety of stakeholders that we're trying to serve with our measurement infrastructure, whether they're in operations, in planning and engineering, community engagement, or sort of the existential value proposition, right? There's a variety of questions that relate to who, what, where, when, and why. And all of these, we want to use measurement data to answer. And we have these diverse set of stakeholders, and how we answer those needs to be tailored to each sort of type of question or story we want to tell. And really the key thing for us is having the right metadata, knowing where to get that metadata and how to safely associate it with the measurements so that we can tell those stories. That really, I think, is one of the key takeaways in where a lot of the work went in the Stardust effort we're about to describe. Next slide. So the journey for Stardust kind of kicked off in the second half of 2020, and I'll get into the measurement working group. But basically, that was a working group that did a strategic review of our institutional measurement capabilities and made some recommendations. And based on those, we sort of we knew we had to look at an alternative to our legacy flow analytics system, and so we started looking at commercial options as well as NetSage derivatives, and in the end, what we ended up doing was creating a derivative of some of our NetSage experience. And we went production in mid 2021. And then from there, what was later named Stardust has sort of just blossomed. And that's why we're here today, right? And so in the current state of affairs, it's really, we're using it as our sort of a universal repository. It's our data lake, if you want to use buzzwords, for all the network measurements. And it's being curated and expanded over time, sort of in an incremental and ongoing fashion. And at this point, we have a majority of our internal needs addressed, and we're starting to look into our broader, let's say, customer base or broader DOE community, look at the needs we can serve there. And we're also starting to look at things in the research space. So how folks that want to use machine learning or AI in terms of network response or tuning. We're trying to figure out how to support those needs in the investigative phases. So next slide. So in terms of this measurement working group, which was sort of I'd say the precipitating or inspiration for Stardust, what we ended up doing was basically getting reps from across the organization and doing a mix of sort of gap analysis or SWOT analysis and brainstorming of what do we think the desired future state should be in 5-10 years. And in the end, basically what you see here on the slide is what came out of that work. It's grossly simplified here, but it basically comes down to knowing who your users are, empowering them with good data, and then allowing them to use that good data to do things like design better services or ensure those services are performing as designed, and basically supporting everything from operations up through architecture and the whole life cycle, right? In particular, the recommendations really centered on ensuring that we were knowing who our internal stakeholders were, continuing to support them on an ongoing basis throughout the full life cycle, and continuing to invest on an ongoing basis, and basically maintaining continuity. So rather than buying a product, throwing it out there, and then watching it sort of not evolve over 5 years, then doing a step function, it was let's continue to invest in that space and iterate and work with the users as their needs might evolve. And as we do this, there was a desire for us to focus on open source or open source derived capabilities and using collaboration where possible to sort of benefit the broader community, but also to sort of mitigate risk, right? And then next slide, I'll let Andy talk about what we created.
Yeah, thanks, Ed. So yeah, so Ed talked about, we kind of went through this whole process in terms of kind of figuring out our measurement needs and all that, kind of across the organization, which eventually led to the Stardust platform. So here's kind of some diagrams of what we actually built, right? And so we kind of came up with, kind of during that process, some features we kind of wanted this system to have. So one was, we tried to kind of lean towards loose coupling of the pieces so we could easily kind of swap things in out as needed. Whether new or better technology came along, or if we're adding new data, we wanted flexibility there to be able to add what we needed to process those. We also kind of tried to lean towards open source, things like that. So the idea is, we could ultimately, share a good chunk of what we came up with, because probably a lot of these, we know a lot of these challenges are not unique to ESnet in that sense. So basically what we came up with is very, and at a very high level is probably similar to a lot of measurement or just data collection systems in general. There's definitely some ideas from like the NetStage project that we pulled in here. So if you're familiar with that project, you'll definitely see some parallels there. So if I start kind of at the bottom, the basic idea is we have a bunch of data collectors, just getting the different types of data that we kind of care about, right? And so everything shown there is actually stuff we are collecting today. There's nothing like theoretical under there, and I'm going to be showing a lot of this in a few minutes. But it's your kind of typical SNMP interface statistics and other good stuff that we get out of SNMP. Flow data, that's kind of our big in terms of events per second data set. We've got perfSONAR data in there. We've got some monitoring data about a lot of the hosts and stuff, like the collectors and things they run. We've got information from our optical system, High Touch, which is an ESnet effort to have dedicated hardware that get basically mirrors of the packets, and you can kind of do unsampled kind of packet inspection and flow inspection and stuff like that, and do some cool things. There's lots of good talks that various people at the ESnet have on that. So anyways, we're ingesting just a subset of that data. But anyways, you grab all that, you throw it on a Kafka message bus, and then you do some data processing. So there's like this Logstash layer where we bring in some interesting metadata, like, look at the IPs. And if we know that those IPs are associated with a particular project or science domain, we can tag that, right? Which later allows us to do some interesting things with it. Then we, Elasticsearch is our primary backend right now. there's a white box over there because we are exploring, maybe there's some use cases where we would, fit in some other backends, and I'll talk a little bit more about those as well later. But right now we run a pretty large Elastic cluster, and I'll also go into the details of that momentarily. And so once it's in Elastic, there's a few different things we can do with it. So one is we can actually run it through some additional processing to like aggregate it, just so it's easier to kind of show later. Do 5-minute aggregations or do some like monthly aggregations and things like that. We can also run it through various like ML jobs and things like that. We've been experimenting with that to do forecasting and things like that. And then also, all of that data in Elastic, there's a bunch of different things that might want to that consume it. So the main thing I'll be showing today is some Grafana dashboards that we have currently internally. We'll talk about maybe that expanding that out a little bit more in the future to beyond just internal ESnet folks. There's also the portal that Ed just mentioned. So if you go to my.es.net, that's all driven by this system. There's also hooks in for Jupyter Notebooks that we've been experimenting with, and we also do a lot of alerting. So that's kind of the quick 1,000-foot view of all the different things kind of going on. So we will kind of zoom into some of these different pieces as we go here and kind of see the end results. So kind of going to the next day, let's just kind of talk about and kind of what's involved in the operating of all of this. Right. So in terms of events per second, so all those data sources that we're pulling in right now, we've got close to about 26,000 events per second that we have to process at peak. It basically, in particular, the flow data, basically throughout the day and in the week, it'll show different patterns. So like, middle of the week, middle of the day, you're going to have a higher flow rate than the middle of the night on, Saturday or something like that, generally speaking anyways. So that's what we have to process. We run a lot of this both in Google Cloud and on-prem. Next slide, I'll kind of talk about what that split is. So Elastic is all in Google Cloud. We have 95 terabytes of storage currently allocated for all of this. Basically the different data sets we keep different granularities. The flow obviously being our biggest one, as you can see there. We keep 30 days of the kind of raw flow data. And then after that, we have 5-minute buckets that we keep for in the order of years, and some 24-hour roll-ups that we keep for basically ever. And we have different rollups for kind of the different data sets and things like that all kind of fit into there. You'll see we have a pretty big Elastic cluster. I think we're at 30 some nodes at this point, 34 nodes kind of. I think we're planning we'll probably be closer to 40 when kind of all is said and done, because we're adding some more data and stuff like that. And that's kind of what we've projected out from the get-go. We also have some nodes for Logstash. There's some general node configs in there. I think the Logstash actually varies a little bit depending on the data source. I think that's our biggest one is what's listed there. Some of them are a little bit smaller. Decent sized Kafka cluster, and just a couple other random hosts that we use for things. So that's all kind of our cloud stuff. And so we have this big infrastructure to deploy. So we use Ansible to kind of maintain all of this. And one important design decision I think it's worth highlighting is, so we have basically Elastic and Kibana and things like that in Google Cloud. We actually tried really hard to be somewhat platform neutral, and that whether down the road we wanted to switch to a different cloud provider or we wanted to move it on-prem, like that would be possible. We're not using any like Google specific services, right? Like their hosted Elastic instance or anything like that. Like we just run it on Google VMs, but we manage installing and all that. Doesn't really look much different than if you had the VM resources locally, right? And deployed it that way. So we've got a bunch of stuff in Google. There's some stuff we run in Kubernetes as well, in the Google Kubernetes service. So you'll kind of see that there. It's possible we might move the Kafka actually to VMs just because we've had some challenges with the Kubernetes setup that we have for Kafka. But things like Logstash and things like that, Kubernetes makes it really, really easy to add new workers and things like that if you need to process some more data and stuff like that. So it's kind of worked well. And then basically all our collectors, largely because of ACL issues and things like that, and policy, those all run locally. So one really nice thing about this architecture is basically Google Cloud. The cloud is never reaching in to like any resources on our network. It's all kind of push out, right? So the collectors grab the data and then they push out to the cloud. The cloud never reaches back in. So that was really one important consideration when we were doing all this and working with our security team on what all this looked like. And then another big piece is kind of the monitoring and alerting. So we actually use something called Elastic Alert, which is an open source tool. If you're familiar with like Elastic and Kibana, this is different than Kibana's like built-in alerting and things like that. This is an open source tool. So basically it allows you to write essentially Elastic queries and alarm on the thresholds and things like that. So we mostly use those for kind of operational, maintaining the infrastructure type things to date. And we could potentially, use it for things like, there's too many errors and discards on this interface type deal, or this, perfSONAR set of perfSONAR tests fell below some threshold or things like that. All of that's possible. Today, though, we use it primarily just for, again, maintaining the infrastructure. This service went down, Kafka lag got too high, things like that. So, yeah, that's kind of the alerting and infrastructure side. So kind of moving up the stack a little bit, and not just kind of running the infrastructure. What do we actually do with all this data, right? Once we have it stored. So we tried really hard, to basically, provide interesting visuals for all of this. So in this slide, it shows kind of like the big raw text records of the different data. And it says not this. We actually do both, right? Because sometimes it's actually kind of handy to be able to look at the raw data. But we also, use Grafana and things like my.ESnet to provide some interesting visuals, and kind of both, coming out of both the NetSage project when we were funded on that, and kind of internally, we've worked to develop a bunch of plugins. So Katrina Turner, who was a grad student at the University of Hawaii and on the NetSage project, when she graduated, she came to work for us, and so she's kind of shepherded these through her various lives as a developer. And so you can see here, there's 6 plugins. These are Grafana plugins. So if you use Grafana, or if you haven't used Grafana before, Grafana is kind of this visualization platform. They have this plugin system for different visuals. It ships with a bunch, then you can do your own. And then they have a system for submitting those to Grafana. And if they get accepted, then it's pretty easy to update your deployment to install those. They provide some CLI commands and environment variables and things that just pull those in automatically. So 5 of the 6 I have right here have already been accepted by Grafana. So if you go to their official plugins page, you will see those. The only one that is not, just because we're still kind of working on it, is this map plugin that I'll show. But the other 5 are all there available for kind of people to use. I think I have some links in the last slide that go directly to those, but if you go to the Grafana's plugins page and search around, you should be able to find them. So you can kind of see them all here. The Sankey, the bump, and the slope actually all started at the NetSage project, and Katrina kind of polished them up when she joined ESnet. The chord diagram here is something we developed, and then this matrix plugin might look familiar if you've used perfSONAR before. That's obviously very intentional, and I'll show some examples leveraging that. The idea is down the road, the perfSONAR project will likely leverage this more tightly to possibly provide a replacement for Mad Dash. One cool thing about it too is it's not even just limited to perfSONAR data. You can do things like, if you have flow data or whatever, basically any data source that Grafana can talk to, it can display cool stuff. So kind of talking about all that stuff is probably not as fun as just showing it. So I'm gonna do a little bit of a demo here, just kind of walking through some of our internal Grafana dashboards. So like I said, this is actually behind. You have to have an ESnet login currently to see all this, but I kind of want to show you some of the types of things that we're doing with the data. I'm just going to refresh here so we have all the latest data. So we have this page, dashboard.stardust.es.net. If again, you're an ESnet employee and come here and log in, you can kind of see all of this. And so you get this kind of initial graph that has a map very similar to my.es.net. And it's got a total traffic graph, which really interestingly, we did not plan this. Clearly there was something happened right before here. So I wasn't planning to do this, but I'm gonna kind of walk you through because it just was kind of nice happenstance that we have this big jump in traffic not too long before this talk started, about an hour ago exactly, almost. So we've got this overview, right? And we've got some breakdowns here on like top interfaces by volume and things like that. So just to look at this and kind of give you an idea of how we kind of use this day to day, I'm going to kind of drill down. So actually, like when this happened, I mentioned our alerting system earlier. An alert actually came in via last alert, and it hit like one of our Slack channels. And I saw that there was a spike and thought, oh no, like what's going on? Because we've got to talk in less than an hour that we have to give. I hope like I'm not showing you really cruddy looking graphs because there's some weird error. So basically the alert was looking at when this number jumps above a terabit per second, which is kind of a tight threshold, and we're having some talks about whether that was the right one, but we had put it there because in the past when we were doing router upgrades, we sometimes get weird results from SNMP. It's just happened a couple times, and basically when it jumped, we just wanted to be able to look at it and see that if some weird SNMP stuff made its way through. But this was much actually turned out to be very legitimate. Nothing going on here. So I saw the alert, I came here, I saw the jump. And so you can then kind of zoom into let's zoom into this window now so we can see what's going on. And so now I see the top interfaces, and I'll see there's basically one at the top of the list. The Nokias are kind of strange in the fact that this is actually like a virtual interface, I'll call it, on top of this physical port. So I'm gonna click here. It's like, okay, so this interface kind of seems to be doing a lot of stuff. So this is going to take us to one of our other pages that's looking at SNMP data still. And you can see, basically nothing's happening. Then there's this big jump at 400G. And if I look down here at the interface information, which all comes from there, I'll see this is in megabits per second, but this is in fact a 400 gig interface. So this is, very realistic for what we're seeing to be able to happen. So it's like, so what's actually going on this? Well, kind of one of the first clues was looking at the interface description. It says BERT, right, which is basically a bit error rate tester. So it implies that there was a tester connected to this. So likely this was some type of acceptance testing. So I with that armed in hand and knowing that I was going to talk to you soon, I pinged our engineering group to see if in fact that's what was going on. And in fact, one of our engineers was at BNL and had just plugged in the BERT tester and has been firing away since then. So that's kind of a really nice graph. The other thing too is that we've been mostly looking at SNMP. If we want to jump into the flow data, right, this kind of helps me build confidence too that this is what's going on. So if we look at the flow data, so this is now all flow data. You get a similar traffic graph from the flow perspective. It matches pretty nicely, so that's good. That's what we expect. Here's our SNMP graph again. And then we can actually even from here kind of drill down into the raw flows. And so that's going. And so you'll see the flow count, right? It's basically seeing one flow every 30 seconds or whatever. So there's just one big flow, right, causing all this. This isn't a bunch of little things going on, right? And we can actually go down and look at the raw flows. If I looked at the IPs and all that, you'd see it's like our BERT tester. The other weird thing about this was too, I had that map up and there wasn't like a big spike on a bunch of the links, right? And so it looks like, he's doing some type of loopback testing is essentially what that confirms. So that was kind of a cool thing that happened right before this. So beyond just, looking at random events that happen and trying to understand that as they go, as Ed kind of mentioned, there's a bunch of other use cases as well that we have for this data. So one of the big ones when we first created this was peering analysis and basically looking at different ASs and peers. So I'm going to jump now to one of our dashboards that's primarily, I think actually all flow data, that you can basically select different organizations by their AS and kind of get an idea of what's going on there. So, this is defaulting to Lawrence Berkeley Labs. If I switch to like Fermi, since they're always interesting and have lots of traffic going, you can see I get the data for the last 6 hours. What's interesting about this is it also kind of shows, again, a big part is this, there's multiple kind of data sets here. So one of the things we do is we correlate flow data with BGP data. And so what that gives us is like the AS path of the flows according to BGP. So if we scroll down here, we can obviously see source and dust ASs, but we can actually also see some of like the top AS paths as well. So you can see some stuff going Jan to Janet, stuff, going to Florida and all that, which is kind of cool. It's also kind of a use case for our engineers, is deciding, potentially, do we need direct peerings with somebody? Because you can actually kind of look through, search by basically stuff that's in the AS path, right? And isn't hopping around or other things like that. So yeah, we can do a lot of cool visuals then too, based on the AS. We can see the top pairs, like who are the top people that the Fermi is testing with, and kind of all that good stuff. So that's kind of one, I think I started off with kind of maybe somewhat operational case looking at that event. This is maybe a little bit more engineering type planning type tool that we might use. Another kind of big user is like our scientific engagement team. So, you might want an even higher level view than this. So we have this thing called the Science Explorer, where you can actually filter traffic. Again, it's looking at flow based on what it's identified as the science domain. So this, excuse me, this leverages some work out of the NetSage project. So there's something called the Science Registry, where people could add information about like IP prefixes and things like that, and the projects they're associated with. And then, using that, we could kind of augment the flow data with that information and filter it like this. So like we can look at high energy physics data and see kind of where it's going. The Sankey graph, which is one of the nice plugins, like I said, that we developed, kind of has a nice way of showing all this happening. If we want to switch to something else, didn't check this before, usually bio can be sometimes interesting. So if you want to switch to biology, it'll kind of switch over to that. Come down to the Sankey here and see it's like LBL's doing some stuff to like NERSC and some other places, right? So a slightly higher level view. So then kind of one last thing I want to show you, some of the newer stuff we've been working on. So I mentioned like the map and like the matrix plugin and things like that. I actually think a good venue to show some of this is actually our perfSONAR dashboards that we have. So for those of you that kind of follow the perfSONAR project, we're kind of in the midst, trying really hard to get something called 5.0 out, which changes how we basically store the results to make it easier to do things in Grafana and other tools and stuff like that. So right now at ESnet, we still run, the normal 4.x version of perfSONAR. We mostly run what are called test points, if that's a familiar term to you. And so basically we collect the data, but instead of shipping it to kind of like the default archive, one cool thing about the perfSONAR toolset is, for many years, it's had the ability to ship the results different places. So we actually ship it to a Logstash kind of data processing pipeline. In fact, the same one that's going to be released with 5.0, and then store that in our Elastic instance. And so we can then do some fun stuff in Grafana with it. And so what we have up here, so I switched to perfSONAR, just to be confusing, this actually isn't using perfSONAR data, these two maps. It's actually using the flow data. And so the idea here is using that engage map plugin that we've developed to actually show where the ESnet to ESnet tests, what links are getting hit. So you can kind of see here, it's kind of interesting. We have a lot of flexibility. So if I go into like the edit mode here, just so you can kind of see what's going on. The topology is actually a kind of JSON blob that we have right now that's here. We're working on turning that into like a database query so it's easier to maintain. But then ultimately how we just draw the lines is we build an elastic query. And all I'm basically asking is from the flow data, we label the application of traffic kind of based on the source and dest ports. So we can identify perf3 stuff if one of the ends is 5201 essentially. And then looking at the source dest ASNs, just constraining it to the ESnet ASNs. Right, so then it can basically, based on the name of the locations from the data in the query, it can map that to the JSON topology and kind of draw it out, right? And so we get all the iperf data that way on the map, which is cool. And then likewise with OAMP. So one interesting thing about this, right, is actually these gray links, the ones we're not testing. So those are actually backup paths. And so we've been having some conversations about testing those. We've actually done this in the past, just basically involves setting up like some tagged interfaces on our perfSONAR testers to make sure they kind of go over the right circuits and all that. The other thing you'll notice is these transatlantic links are all gray right now. So again, we're constrained to ESnet test. We have some tests that are testing things across the Atlantic that are not at ESnet, but so as part of the ESnet 6 deployment, one thing we're still waiting on, I think it might even actually be happening next week, is our European perfSONAR testers haven't been deployed yet. So once those are deployed, those should be lit up. But you can very clearly see that they're not there based on this map. Okay, so anyways, that was just kind of showing off the map a little bit and some of the flow data. Let's actually get into the perfSONAR data itself. So here, we kind of have some highest throughput and packet loss. If we go down here far enough, we'll see some of those matrices I was talking about. My computer wants to load them. Oh, there they are. Of course, right when I hit the refresh button. So anyways, here, instead of waiting for all that again, let's just jump into this because so if you're familiar with perfSONAR and you use the tool we call Mad Dash, basically we've kind of recreated Mad Dash on this dashboard here. And so just waiting for load here. Okay. So you'll see we have kind of this dashboard here. Again, if you've used Mad Dash before, you can kind of select the dashboards. It's very similar if you've ever been to ps-dashboard.es.net. That's a public page. Basically is recreating that. So you see there's lots of red here. And so if you look at like ps-dashboard.es.net, it's not quite the same because our thresholding is a little different. And actually one cool thing about it is it's a little bit flexible in the time range you're looking at. So right now, all of these are looking at the max packet loss over this 24-hour period. So if I want to constrain that to the last hour, I can do that. You'll still see quite a bit of red. So there's some stuff for debugging in Denver. And then you'll see a lot more with our IPv6 test or our IPv4 test. This is actually a problem that we have been trying to track down for a few weeks now, is there's something different about our IPv6 setup that we're trying to figure out that's causing like this pretty kind of constant low level of, well, it's not constant, but it's causing like some pretty noticeable packet loss more frequently than our v4 test. So yeah, so there's a bunch of things at the host level we're trying to debug and stuff like that. So I don't have good answers here, but it's kind of cool that you can see it. So if I click through, just like Mad Dash, you'll get your throughput tests and retransmits kind of here. You can scroll down, look at latency, all that. You can see here this weird negative number. That's when we did a host reboot a couple days ago. We do monthly reboots just to update kernels and all that good stuff. And then those of you familiar, basically when NTP comes back up, it doesn't always quite sync right away. It takes a minute, so you can kind of see that happening there. And here's some of that packet loss that I was talking about, kind of jumping around. We've got good jitter graphs, things like that. We've also got some starts of some trace routes. I think there's some cooler stuff we can do with actually using the trace routes and probably showing SNMP counters and stuff like that. We don't quite have those going, but you can see all that. So one other fun thing I kind of wanted to show, I think it's maybe easier to see with the throughput test actually. So let's go find some throughput testing. I'm gonna jump And if we go down here, I'll just pick a random throughput test. Great. Yeah. Oh, it thinks I changed, but let's go. So you'll see these up here too. So I was kind of showing the map earlier, and it was looking at all iPerf3 traffic. Kind of similar to the very first kind of graph that Ed showed. You can constrain it even more, right? So if I load this one, there's a map right here. Should be. Sorry, my computer is being weird today. There we go. So we can basically see all the flows kind of coming out of Albuquerque, and where they're kind of going across the network. So you can kind of see that query here, right? All right, there we go. So again, we've constrained by perf3, and then we've kind of looking at the source and dest IP to see if they match, basically the IP address behind this. And you can imagine too, if you had two endpoints, that's how we do things like draw a single flow across the graph. We can do all that. And then I mentioned kind of the flexibility of the matrices. So I'm not my usual computer. This one is noticeably slower than the other one. So I'm going to be blaming that for all this fun stuff. You got all these fun wait times. So basically there's, I'm sure they'll load eventually. There's some matrices that just basically look at all the tests on this host, right? So not kind of like the pre-baked ones that you can think of. Mad Dash, you can go, yeah, there we go. Be a little bit more flexible, so you can kind of see all the tests here. And you can see that like our throughput interface actually has some late packet loss tests on it. It's actually us trying to figure out what's going on with that packet loss problem I mentioned. We were seeing what happens to those tests. So anyways, that's basically all I wanted to demo. And so the kind of last few things I want to cover is just some kind of additional work that we're doing and some stuff that's kind of coming down the pipeline that might be interesting to folks. So we got a number of other efforts kind of we're working on to kind of enhance the service. So I mentioned like, the SNMP stats a lot. We're actually right now very actively looking at streaming telemetry and have been doing a bunch of testing with that. So basically this is essentially a different model for getting the stats instead of, polling a bunch of OIDs periodically and things like that. It's basically more of a kind of push subscribe model where we can kind of get the data. And so kind of the typical case for streaming telemetry, we've kind of run into in real life, right? Which is we've been adding more and more things that we want to pull. We've started to basically hit limits with the network devices themselves, being able to return the data fast enough. Or like we've had cases where we've had like multiple collectors and those multiple collectors kind of bump into each other. So we're mostly grabbing things at like 30-second resolutions. In theory, streaming telemetry would hopefully better scale at that resolution and also probably let us do maybe even higher resolution if we so desired. We're also looking, there's some nice data models in streaming telemetry. Maybe this is personal preference, but especially compared to the SNMP MIB structure and having to navigate all those. So we're looking at things like OpenConfig. We're not quite sure. That's basically kind of an open standard for how to model a lot of this data, which, if we stick to that, in theory, we could jump through different vendors and things like that, and things would, look the same. We're kind of trying to figure out now the balance there in terms of having to use the vendor specific stuff versus that, but kind of all things that we're exploring. And we'll probably be moving to this here pretty soon. Another data set we're kind of looking at, and so I mentioned we collect BGP data to essentially adorn the flow data with AS path, but we don't actually like store it as a first class citizen. But that's something we're looking at doing, where basically we'd have periodic snapshots of the BGP table, could maybe do some things like a looking glass kind of like over time. The other thing we're looking at, the BGP monitoring protocol, or BMP, it has a bunch of useful information about up-downs events, when update and withdrawal messages come in, and a bunch of statistics about the RIBs and all that. So we're kind of looking at storing that, and there's some uptime report use cases and different things that we think that would help with. Then one other thing I had mentioned earlier, that white box where next to Elasticsearch, like looking at alternative data sources. So the high touch data set, which is like these unsampled packets, they've been having some success kind of storing all that raw data in something called ClickHouse. It's a column-oriented database that's got kind of a SQL-like query language that you can run against it, and they're doing some interesting analytics. So we're basically working with them to figure out how we can help productionalize that and make it more widely available, and things like that, and integrate that data with the data we already collect. And then one other big effort, so I mentioned the Jupyter Notebooks. So there's something called ELAND. There's a link to, or I'm sorry, ELAND-D. We were corrected on our pronunciation of that at some point. It's basically a way to an interface to Elastic to turn the API into like a Pandas compatible API. So then you can use notebooks and Jupyter Notebooks and stuff like that. The idea is researchers who are more comfortable in that platform could use interface like this for that data. We're also, Elastic has some enterprise features around machine learning, mostly around anomaly detection and prediction. We've been playing around with those to see if there's any useful bits there. It's mostly just kind of in the exploratory phase though, so no results yet to share, but maybe in the future. And then kind of the last one, and probably our biggest effort of all of these, is we're looking at how to do some customer portals. So specifically, we've got a cross-group team very similar to what we did with the base measurement infrastructure at ESnet, to kind of look at the UX, or the user experience for all our tools, both customer-facing and internal-facing at ESnet, and how we can make those more consistent. Part of that is, so we've got the my.es.net portal. Today, you can kind of go there and poke around. I think there still technically is a login, but it doesn't really change too much what you see. So we're looking at how we can basically use OAuth or things like that to authenticate people, and then maybe give them some more access to resources that they don't have as easy access today, or is maybe split across multiple tools. So things like tickets, or maybe uptime reports for the site or organization that you're associated with. Another cool one might be a more granular view of like the flow data that we collect, right? So right now, for the public stuff, we obviously don't want to expose IPs or anything like that, so it's very much aggregated. Yeah, one could imagine a portal where you log in, and like if you're associated with the site, maybe the flow data associated with your site, you could potentially see more of that information. So we're actually looking at using Grafana Enterprise potentially to help with some aspects of this, and maybe even give people some custom dashboarding capabilities. The big thing there is like the OAuth and SAML features that it has that would kind of enable that single sign-on. So we can more easily do that, and limit people access to the right set of data and stuff like that. And kind of the ultimate goal is to get the seamless experience again across all the tools, while providing some more capabilities for end users and people. And then I guess just kind of wrap things up. Yeah, that's all I had. So there's been a lot of work. I know it's sometimes a fire hose of information when we show this, but hopefully there were some useful bits there. And I think we've got 15 minutes left if people have questions.
All right, Andy. Well, thank you for going through all of that. Certainly, yes, it is a fire hose, but a lot of good stuff. I have a first question while we wait for people to sort of enter that information into the chat room, or just put your hand up and I can unmute you. You showed some of the perfSONAR data a little bit earlier, and I was looking at a perfSONAR dashboard earlier today for a similar issue, looking at some of the reboots that you had made on machines. Do you get the same fidelity of information via this that you would from perfSONAR, where you can still get the same exact data that you would just looking at PS dashboard that you would right now, or is it sort of a slightly different presentation?
Yeah, so you get the same fidelity of the data. At the end of the day, the stuff in the database is like exactly the same in terms of granularity that you have in kind of your typical perfSONAR install. basically the difference is just with Grafana, in particular, if you have edit permissions and stuff, you have a little bit greater control over those graphs. Like for example, right now in kind of your typical perfSONAR installation, there's a pull down where you can select like the time range. And if you select 24 hours, you get kind of a fixed bucket size. I can't remember what it is, if it's 5 minutes or what. You have a little bit greater control over that in Grafana. If for whatever reason, you're able, if you want to look at, maybe don't aggregate it by 5 minutes, right? Like give me the 5 minute raw OAMP results, right? Or not 5 minute, the 1 minute kind of OAMP results or things like that. So it gives you a little bit of flexibility there. The other piece too is I think the graphs basically limit the stat that you see in most cases. So I think it's the min latency that we see on the graphs for a typical install. Obviously with Grafana, you can query whatever you want. I think on some of those graphs, I had multiple things going. So you can do, min, median, 95th percentile, all that good stuff. So it gives you a few more options to play around with in regards to that, and basically just more flexibility.
Okay. Jen has put a question in there. I'll read it out. Are there any plans for opening up more of this data for people who don't have an ESnet login?
Yeah, so we have, there's a link right there. There's something called public.stardust at ESnet where we've put a few dashboards for the LHC community. We're also kind of constantly developing the portal and figuring out what we can add there and things like that. A lot of it just comes down to working with our security team, and it's policy related, like about what we can actually share and show. We've got the Department of Energy is in charge of like our nuclear arsenal. So there are certain sites we have to be sensitive about what we share, and especially in addition to all your other typical stuff. So we do our best, and we're constantly figuring out. I don't know, Ed, is there anything else specific worth mentioning?
I think the part of it is, Jen, I think to your point, I mean, we do have a set of data which we have is deemed sort of the equivalent of non-sensitive to share that we aren't yet through the portals, like the optical data. And we're working, there's a two-pronged approach there. One is we've been refining our sense of what is safe to share and have a good sense of that now. Some of that we probably, if they were interested, we could do some of that through the public Grafana dashboard. The other part is as we sort of get through, we're working on doing some map refinements to the my.es.net portal, but there'll probably be some enhancements there as well in the ensuing quarters. And we're still trying to figure out where's the best place to put certain data depending on what the user scenario is, right? So the portal is sort of almost like an advocacy kind of a thing. It's not necessarily network research oriented. So depending on what the data is and how it's used might guide it going into one direction or the other. But plans, yes. Firm plans, we're still working on that.
All right. Do we have any other questions that people may want to ask? Oh, looks like we just got one. Doug is asking, are there any plans for stakeholders, LHC, to subscribe and receive some data to inject into its data analytics system?
So I will say, we actually have APIs to, like public APIs to a lot of this data as well. So that's kind of information that they could pull in. We have done work for like some of the LEC data challenges as well to pull in some of the Firefly data as well that people have access to. I don't know of any specific plans that kind of fall into that realm beyond those, but we're kind of very kind of in touch with that community. So I mean, obviously anything we can do to help, we'll try to do.
And architecturally, I would say we are anticipating a future where I'll say systems to system data integration becomes increasingly desired, and controlled sharing of data will become inevitable in more of a ubiquitous sense. So we're planning for that from a technical perspective. Yeah.
All right. We'll pause again and see if anybody else has any last questions, but I'll thank you both for going through this. Really, really informative. And hopefully you'll keep us all up to date on any new deployment, or I'm sorry, any new developments and findings. And if you do need beta testers, I'm sure there's probably 35 people on the call that are willing to help you with that.
All right. Yeah. Thanks, Jason.
Thanks for having
All right.
us.
Thanks all. We're going to be on a 2-week pause, so we will pick up in about 2 weeks. Hope everybody has a good couple days off, and we'll talk to everybody soon.